everyone. So today we need to continue our second chapter, the essence of change, and we need to start from the topic which are mentioned in page number 22 onwards. Before that, I need to mention you something. Even though I have posted many homeworks and all, there are still some students who are reluctant to send these works. You have to send it as soon as possible. And one more thing, I have already informed you the fact that due to these difficulties, you need to send the unchecked notebooks, unchecked notes, and the answer sheets to a separate number. I have posted the same in our group, but there are still many students left to send the notes as well as the question paper. Also, I need to tell you one thing. I may not be able to check the answer sheets or the notes as soon as you have sent it to my WhatsApp, because there is actually a pile of notes or answer sheets to be checked due to these online classes. So it will take some time, but you do not show any hesitation to send these works to my number. Okay. So I do not want to continue all those talks and all. Here we need to fill a flow chart in page number 22. It is associated with the energy change shown by a generator. What is it? Generator. Do you know what is a generator? You might have seen it in houses where some functions are going on, right? Generator. What is it used for? It is actually used to produce electrical energy. A generator is used to produce electrical energy. It generates electrical energy. A generator generates electrical energy. Now, in order for a generator to work, some kind of fuel need to be filled. For example, usually we fill it with diesel, right? Or kerosene or petrol and so on. So a generator is a device used to produce electrical energy, and it requires some kind of input, some kind of energy. What is the energy a generator is used for working? It uses the chemical energy of fuels. Okay, fuels contain chemical energy. So when fuel is burned inside generator, it produces chemical energy, and using this chemical energy, a generator will work. What is the purpose of a generator? It generates electricity. Generator produces electricity. Now the thing is that, as we discussed in previous classes, this generator also produces different kind of energy. Okay. The first thing, a machine is working. Generator is a machine. When it works, basically what is the energy produced when a machine works? It is mechanical energy, right? Mechanical energy. So you need to fill here mechanical. Okay, you need to fill that column below a generator working. You write there mechanical energy. And below mechanical energy, you can see three columns, three separate columns. What exactly is that? That column is actually intended for, 1 minute. Yeah, that column is actually intended to fill what energy are actually produced when a generator works. So first of all, generator require chemical energy. Generator is working, so it produces mechanical energy, right? Or the energy associated with the machine, or when the machine part moves, is called as mechanical energy. Now, whenever that mechanical energy is there, whenever the machine part move, what are the other energies produced? One energy, definitely there will be sound, right? There will be noise, not just sound, there will be noise. Along with the noise or the sound, there will be heat also. Now both of these energies are produced whenever a generator works, but these are not what we require, right? Along with these two, the prominent energy which is produced by a generator, it is which one? That is electrical energy. That is the purpose of a generator. Electrical energy is the energy which is mainly produced by a generator, and that is why we use it. So what do we discuss till now? What did we discuss till now? A generator or electric generator, it works using the chemical energy of fuels. Using that chemical energy, generator will work. So generator works, which means a part of a machine, or which means a machine is working, which shows the energy associated is mechanical energy. By that energy, or using that energy, by moving the machine parts, we are actually producing electrical energy, heat energy and sound energy. Here the sound energy is one of the energy which we are not using, and heat energy is another energy which we are not using. The only energy which we use is electrical energy. Is that clear for you? The only energy which we use is electrical energy. And what is the purpose of electrical energy? It can be used to work different electrical equipment. You can see here actually a mixer grinder working, a fan working, and a bulb glowing. In between, I need to mention you one more thing. Actually, under the topic and generator working, you can see a single column. Okay, below that box, you can see three another boxes, right? Below those boxes, you can see it is mentioned as not used. It is true that two of the energies produced by a generator are not used. Which one are they? One is heat energy. We are not using heat energy produced by a generator. Another is sound energy. We are not using the sound energy produced by generator. But you should keep in your mind, we are using electrical energy produced by a generator. So even though the first two, they are not used, the electrical energy is actually used. So if that second column, second box, if below that you are seeing not used, some of the book you can see that it is written as not used. If it is the case, please cut that. Okay, it is actually used. You cut this not. It is used. So now what are the uses of electric energy? That is mentioned just below that. What are the uses? A mixer grinder is working, a fan is working, and a bulb glowing, right? So below a mixer grinder working, there are actually two boxes. In one box you have to write regarding the energy which is used, and in another one the energy which won't use. Okay, which we won't use. First one, used energy. In case of mixer grinder, or what we call it as mixie, right? Mixer grinder, we use the mechanical energy. Mechanical energy is used. But what are the energies we won't use? We don't use. Sound energy is one of the energy produced by mixer grinder that we won't use. Likewise, heat energy is another energy produced by a grinder which we won't use. Now in the case of second one, a fan working. Regarding a fan, you can see that the fan is working, the fan is moving actually. If a machine moves or a part of a machine moves, then we call that energy as mechanical energy. It is the energy that we use in case of fan. So mechanical energy is, it is to be written under the box used. Okay, you can see below that used. Now in the another box, whenever a fan works, you can see that that rotating part, the motor, it heats up. So what energy is that? Heat energy is there which we do not need, which we do not require. So the energy which we won't need is heat energy. Likewise, is there any other energy which is produced from a fan? Sometimes you can also hear some sort of sound. So that is also energy produced by fan which we do not require. Now next one, a bulb glowing. Whenever a bulb is glowing, already we discussed, it produces light energy and heat energy. Which energy do we use? We use light energy and we won't use heat energy, right? So fill that accordingly. That was a simple box. I will tell you the answer once more. Below a generator working, you can write mechanical energy. What is that energy? Mechanical energy. Now below mechanical energy, you can see three boxes. In three boxes, you need to fill it with the energy produced by this generator. One is heat energy and another is sound energy. Below this, you can see not used. Sound energy we are not using of, heat energy we are not using of. We are only using the electrical energy produced by a generator. So suppose in your textbook, if you can see not used here, you should cut this not. Actually, it is used. Now below this, you can see three examples or three electrical equipment working with electricity. One is a mixer grinder, another is a fan, and another is a bulb. In these three cases, you need to write the energy which you are using and the energies which is produced but we are not using. In case of grinder, even though it produces mechanical energy, then heat energy and sound energy, the energy that we use of is mechanical energy and we won't be using heat and sound. So you need to write heat and sound in second box and mechanical energy in first box. Likewise in the other cases also. Now what is the topics that we discuss in page number 23? You can see three pictures there. One is that of a stove, or what you can say, a stove is burning, right? Now second one is actually a firecracker and third one is a torch. Which form of energy undergoes change in each situation? What are the forms of energy produced? In first case, we know that firewood is burning. Firewood is burning. So whatever be the material, if it burns, here it is producing chemical energy. Okay. So firewood is burning, which means firewood contains chemical energy. Chemical energy is converted to which all energy? Heat and light. There is a change. We are using chemical energy and the energy produced are heat and light. Now in second case, there is a firecracker, and I told you already, a firecracker, if it works, it contains some chemical and the energy associated is chemical energy. And when the chemical energy is used to burn a firecracker or when it is converted in firecracker, it produces light and sound, right? Light and sound. In this case, it is almost a sparkler, and the main energy we use might be light, but you have tried both. Okay, you have tried both because the question is what are the forms of energy produced. In third case, you can see it is a torch. Usually the torch contains a battery, right? Some batteries will be there, and inside the battery there are some chemicals. So the energy inside a torch is chemical energy. Now here chemical energy is converted to light energy and heat energy. Whenever a bulb glows, or usually whenever a machine works, there will be some energy lossage in form of heat. Okay, that is the case. Now what else? Which situation in the given picture does not use light energy? In first picture, right? In first picture, even though light and heat is produced, we are only making use of heat energy and we do not require that light energy. In which situation is sound produced? In second case, sound is produced. It is actually firecracker, so sound is produced. In which situation is heat energy made use of? In first situation, because in first situation, even though heat energy and light energy are produced, we are making use of heat energy. We have understood that there are different situations where one form of energy transforms into other forms of energy. It is true. We have discussed that in all these cases, one form of energy is converted into other form. What is the change that takes place in a substance when it receives energy? So the textbook is asking you, if one substance receives energy, what does happen? I will tell you one thing. Consider you are having some ice cubes with you. You are having some ice cubes. Now, Fidaman is going to heat these ice cubes in a vessel. She took this ice cube in a vessel and she is going to heat it. Okay, let me draw a small candle or something here. So she is going to heat this ice cube. What will happen? Ice cubes, they are actually solid, right? Solid. When they are heated, this ice cube will be converted to water. And again, she is not stopping. She again heated this water. What will happen if Fidaman again heated this water? What will happen? Water will be getting converted to water vapor. Isn't it true? Do you understand what I mentioned? Fidaman had some ice cubes. She heated it. Now ice cubes, they are solid. Have you heard of solid? We will be discussing in higher classes, but you just keep in your mind, ice cubes are in solid form. Now when we heat it, the ice cube just converts into water, and when we heat the water, it is converted to water. But do you know this? This is a usual thing which we are already familiar of, right? Now let us go to the topic. Already the textbook asks you one question. What is the change that takes place in a substance when it receives energy? Now we are going to answer it by discussing the topic when ice melts. Try doing the experiment given below and write down your solution. You need to do this experiment. Take some ice cubes in beaker and heat it as shown in figure. I told you Fidaman is doing that for us, right? What change do you observe? What are the things you can observe? 2 points need to be written. Now, what are the things you observe when ice cubes are heated? One thing is that ice melts and form water. Okay, ice melts and form water. That is one of the thing that you will see, you will observe. Now what is the second thing? The ice cube, they are melting, but their temperature, that coolness, it is still there. Even though ice melt, that the temperature, coolness is still there. Which form of energy was utilized by ice to undergo the change? Which energy is used? Heat energy. Which is that? Heat energy. Okay. So you need to write ice melts. That is first point. 2 points need to be written. First point is ice melt. Second point is it forms water, or it is changed into water. I will write it once more. So first point, ice melt. Ice melts. Second point, what is second point? Second point, you need to write ice is converted or changed into water. That are the two things you can observe. Which form of energy was utilized by ice to undergo the changes? Heat energy is used. So you write the heat energy. Okay, heat energy. I will write it once more. Heat energy. Okay. Now heat the water obtained. So you obtained water by heating ice cube. You got some water. Again you need to heat the water. Note down the changes. So what is the change? water is converted into water vapor. Water is converted into water vapor. Again it absorbed heat, right? The water absorbed heat and it is converted to water vapor. Now what else? Can the steam be converted back into water? Now you got water vapor or steam. Water vapor is also called as steam. So you got steam. Can we convert this back into water? Can you convert the steam produced back into water? That is the question. It is possible. Actually, it is possible, and in our home we have seen it many times. If you close a vessel which is actually cooking or something is inside it and we are boiling that, and if you close it with a lid, whenever you remove this lid, you can see water molecules under the lid. Okay, lid means അടപ്പ്. നിങ്ങളൊരു പാത്രം അടച്ചു വെച്ച് എന്തിനു കുക്ക് ചെയ്യാണ്, പെട്ടെന്ന് അടപ്പ് എടുക്കുമ്പോൾ നിങ്ങൾക്ക് അതിന് താഴെ വെള്ളത്തുള്ളികൾ ഇങ്ങനെ കാണാം. ഫ്രം വേർ ദാറ്റ് വാട്ടർ അറൈസ്ഡ് ഓർ വാട്ടർ കെയിം? That is actually the water which was evaporated from this beaker. ഈ ബീക്കറിന് ഇവാപറേറ്റ് ചെയ്ത വാട്ടർ നമ്മളുടെ ഈ ഒരു വെസലിൻ്റെ അല്ലെങ്കിൽ ലിഡിൻ്റെ മേലെ വന്ന് നിന്നിട്ട് തണുത്ത് അതെന്തായതാണ്? വാട്ടറായി മാറിയതാണ്. സോ നമ്മളിപ്പോൾ പറഞ്ഞു ഐസ് ഹീറ്റ് ചെയ്താൽ, ഐ വിൽ റൈറ്റ് ഇറ്റ് ഹിയർ, ഐസ് when it is heated it is converted to water, and water when it is heated it is converted to vapor. It is true. Now you can convert vapor back into water and water back into ice. How we can do that? We can do that by cooling. Okay, you know this water can be converted to ice. How? We keep it inside a fridge, right? We keep the water inside fridge, we can convert water into ice. Likewise, the vapor when it is cooled we get water, and water is cooled we get ice. This is the topic which the chapter is trying to tell you. We'll see the rest. Go to page number 24. Examine the figure and discuss the materials to be used to conduct the experiment. Blah blah blah. We need not to. There is no need to tell, or we need not to discuss all those topics now. We will see it from the classroom itself. Can the experiment be carried out more effectively by placing an ice cube on the watch glass? The steam is again converted to water through this experiment. Now, can the water be converted to ice again? I told you by cooling water we can get ice. Ice absorbs. Now, textbook is trying to tell you what will happen if you heat ice. Ice absorbs heat energy and changes into water. It's liquid state. So, I told you there are actually three states. Which are they? Solid, liquid, and gas. Ice is in solid state. Water is in liquid state. And gas, that is steam, is in gaseous state. Whenever we heat ice, it absorbed the heat and it was converted to water. And whenever we heat water, it will absorb the heat and it is converted to steam. Whenever you cool the steam, whenever you lower the temperature of steam, it is converted to water, and water when it is cooled, it is converted to ice. Did you get it? Okay, so whenever ice get heat, it is converted to water. When water loses the heat, it is again converted back to ice. Actually, these are the states, these are the forms in which matter exists. Matter, we will discuss regarding matter soon. So these are the three states of matter, three states of whatever substance you are dealing with, they will be in these three states. Okay, so these three states can be converted. We can convert a solid into liquid or a liquid into gas by changing the temperature. If you heat a solid, it will be converted to liquid. If you heat a liquid, it will be converted to gas. By cooling a gas, you can get liquid, or by cooling a liquid, you may get solid. So the change from one state to another, from solid to liquid, or liquid to gas, or solid to gas, or back from gas to liquid, or gas to solid, these are called as, or these changes are called as change of state. What is it called? Change of state. So change from one state to another is called as change of state. So I will give you a question here. Give a brief note on change of state. So you write the box as the answer. You need to copy this to your notebook itself. Regarding this chapter, there is no requirement of more notes and all. You should be thorough with examples. Okay. The notes need to be given for some of the topic which we will be discussing from now onwards. Now I gave you homework. Give a brief note on change of state. Okay, brief, B-R-I-E-F. Give a brief note on change of state and write this box given in page number 24. Also, you need to fill the box, that change of the ice cube from solid state to liquid and back to ice cube. You can see it here, a box. You need to fill it. Okay, I hope it is clear for you. We'll see the rest of topic in next class. Thank you.